This is the OFI testing equipment Garrett gas train, our part number 151-00. We sell this in a kit, and it has multiple uses. Most people use it for testing for H2S, or hydrogen sulfide gas, which is very toxic, poisonous, and corrosive. But you can also use it for testing for carbonates also. And we give you all of the equipment and tools and reagents to do both the H2S and the carbonate test. What I'm going to do now is a test for hydrogen sulfide. Basically, in chamber number 1, we put our filtrate, which is liquid that has no solids entrapped in the fluid. So it's a clear liquid only, and we're testing for soluble sulfide. Soluble sulfides include hydrogen sulfide. It also includes sulfides. It also includes hydrosulfide. And we acidify the solution with a sulfuric acid solution, and that converts all of the soluble sulfides to hydrogen sulfide, H2S. So basically what we're doing in chamber 1 is we're making H2S, and then we're using the CO2 cartridge or CO2 bulb as a carrier gas to carry the H2S from the first chamber through the second chamber into the third chamber and into something called a Draeger tube. Draeger tubes are very nice analytical tools which enable us to test for various elements, various ions. There's a lot of different Draeger tubes that a person can buy. Specifically, the ones that we carry for this test are the low-range Draeger tubes, which have a range of 100 to 2,000 parts per million, our part number 151-02, and then the high-range tubes, which is the it measured in percentages, 0.0 or 0.2 to 7% by volume, H2S. The low-range tubes are the little short tubes like so, and then the high-range tubes are blue in color. This is a test that we did yesterday. In the presence of hydrogen sulfide, they will stain, and the length of this stain gives you an indication, a very good indication, a quantitative indication of the amount of H2S gas that is present. So that's what we're going to do today. Another way of running a test, a qualitative test, if you don't know if you've got sulfides or not, if you want to run a quick test, you can use something called hydrogen sulfide test paper, more commonly known as lead acetate paper. This comes in a circle. It has a bluish green color to it. In the presence of sulfides, it will turn dark. The higher the milligrams per liter or parts per million concentration of sulfides, the darker it will turn. In other words, it will turn black in a high concentration. It will turn a light brown to brownish color in a low concentration. These are good for up to about 50 milligrams per liter. And a good quick test is you put this in chamber number 3 in the Garrett gas train, and you run your test. And if you get a positive, if this turns color, then you know that sulfides are present. That will give you a good indication of whether to use the low-range Draeger tube or whether to use high-range Draeger tube. This is also a bottle of 100 papers of these is also included in the Garrett gas train kit that we sell. So, as far as running the test, the first thing that you do is you add 20 milliliters of deionized water to chamber number 1. I have already pre-mixed or pre-measured that out, so I will just dump that into chamber number 1. Next thing I want to do is I want to add 5 drops of octanol defoamer, which we have in a 2-ounce bottle or 60 milliliters. So 5 drops would be 1, 2, 3, 4, 5. So that's it as far as that goes. Now, I want to carefully add the lid, or place the lid in position. Be careful, this is the dispersion tube. Some people call this a fritted disc. This dispersion tube has a filter on the bottom. And we filter our air through this, and this traps any particles that may come through the air pressurization system. I very carefully put this in place. This breaks very easily, so you want to be very, very careful with it when you put this in. Also, this is the flow meter. This gives an indication of the flow trend, and I want to keep my black ball in the flow meter somewhere around this lower horizontal line. So very carefully line up my flow meter, my dispersion tube, lower this gently in place. I want to make sure that my O-ring seals around chamber 1, 2, and 3 are in place, and they are. So I can now tighten my set screws. And you want to roughly tighten all of these equally at the same time, because in tightening one, you're going to lose something else. So you want to get a uniform tightness. You don't want to over tighten to where you break the lucite cap, because that can be done. So you want it snug tight, but not gorilla tight, so to speak. You want to make sure that your inlet pressure from your regulator is attached to the regulator and is attached to the top of the dispersion tube. Here we have a rubber hose coming out of chamber number 3, and I'm going to attach that to my Draeger tube. In this case, I'm going to use a high range Draeger tube. And in order for these to work, I have to flow the gas through the tube. When they're purchased, these tubes are sealed. So I want to take a special tool, which is also a part of the kit, and it has, if you can see those teeth there, that is for breaking the end of the Draeger tube, and you just basically put it in here and twist. Very simple. The Draeger tube, these are marked with an arrow, and you want to make sure that the arrow is pointing down when you put it in the special tube, special cylinder for the Draeger tube. On the low range tubes, you can see the arrow maybe a little bit better there. But also it helps to, if you just kind of moisten this a little bit, because this is a very tight fit. There's an O-ring seal in there to prevent leakage. And you want to be careful when you push this in that you push it straight down, because you can break the tube if you put it in crooked. So the Draeger tube is in place. The rubber hose from the chamber number 3 to the end of the Draeger tube. I notice my flow meter valve, I just knocked that down with the syringe. All right, so everything is ready. I want to check, ensure that my regulator T-screw is backed off. I want to put a new CO2 bulb in place. I had one in there already that may have sufficed for the test, but I always like to start off with a new one, so we will do that. we will tighten it down enough to puncture, but not over tighten, not to not put too much of a hole in the end of the cartridge or the end of the bulb. So now I am ready to run my test. What we're using for sulfides is a 10% solution of sodium sulfide, and that will be the sulfides that we're going to be drawing the H2S out of. The acid that we use is a 5-normal sulfuric acid, which is our part number 230-13. You can get this in different sizes, 2 ounce, 8 ounce, 16 ounce, 32 ounce. We sell a lot of that. So to start the test, I have make one last visual check. I want to make sure that everything is in good order. I want to make sure my dispersion tube, the disc, the filter, is about 1/4 of an inch off the bottom of the chamber. And it is. So we're in good shape there. So it looks like everything is good to go. My injection port, my rubber injection port is in place. I use that for injecting the material, the acid and my test solution into chamber number 1. And my Draeger tube is in place. My tubes are all good. Everything is tight. So we're ready to go. So I'm going to inject roughly, I'm going to try 5 milliliters of sodium sulfide solution. Actually, I will inject 3 milliliters since I got a 3 ml syringe. It really doesn't matter. We're not so concerned with numbers here. This is just demonstration. So there is my 3 milliliters of sulfide solution that I have injected. Now, next thing I'm going to do is I'm going to inject 10 milliliters of my acid. And we can now smell the sulfide, the rotten egg smell rather strongly. So I want to do this as quickly as possible and then start the test. So there's 3 mils. There's 6 mils. It would work better if you had a 10 mil syringe with a needle. By the way, these syringes with needles, when you're finished with them, you have to take the needle, bend it, break it off, but make it so that this syringe with this needle cannot be used in an illegal fashion, which is not the way it was intended to be used. All right, so we now have our solution, our test solution, chamber number 1. I am going to very carefully, and I don't want to overdo this, initiate my gas flow through the regulator, my CO2 gas flow. So I'm looking for bubbles here. And I'm also watching my flow meter bulb. So if you can see that, if you can see this up here, my Draeger tube, the stain length is coming down. This, as I mentioned, is a high-range Draeger tube, specific to hydrogen sulfide. And this is indicating that the test is working as planned. My CO2 carrier gas is carrying the hydrogen sulfide, which we're generating in the first chamber, with the acid through the second chamber, through the third chamber, and through the Draeger tube. And you can see the stain length is coming down. We may peg out this Draeger tube. But this is the reason for running the test. When you run the Garrett, it's best if you get the Draeger tube to stain at least halfway down, because that way you get a good analytical test. Looks like I'm losing some pressure, so you have to constantly monitor this. You have to keep watching this. So I have pegged this out. So if I would rerun this test, which I would have to do, then I would use a smaller quantity of sodium sulfide solution. Instead of using 3 mils, I might use 1.5 mils, something like that. But I certainly would want to use a smaller amount. And the test procedure says to run this test for a minimum for 10 minutes or 15 minutes. Actually, you continue flowing for 15 minutes and continue collecting data in your Draeger tube. Since we have already maxed out the tube, there's no point in continuing this test, so I'm going to go ahead and abort it as of now. And in order to do that, if you can see here, my the valve, the little ball on the flow meter is just below my lower mark. The instructions say to keep it between these two lines. I don't know how necessary that is. I found that it helps to keep it closer to the lower line, but that's up to you. It's just the way I do it. I try to keep it more down here rather than more up here. But since we've already maxed out the high-range Draeger tube, we generated a lot of hydrogen sulfide gas, so I'm going to abort the test. I will back off on my regulator all the way down, which alleviates the inlet pressure from my CO2 bulb, and I can now retrieve my Draeger tube. And the formula that we go by, the way we measure this test, is that we're measuring sulfides in milligrams per liter or parts per million. And we don't differentiate. In general, when we say milligrams per liter, that equals parts per million, or ppm. So the formula is the darkened tube length times the tube factor divided by the sample volume. So in this particular case, we've got a, if I can get this out without breaking it. All right, I've got a tube length of 7. I've got actually beyond 7, but I could only measure 7. So my darkened tube length would be 7. The tube factor for the high range tubes is 1500. So the tube factor for the low range tubes, for the short range tubes, is 0.12. So the tube factor for this is 1500. So my sample volume that I started out was with 3 milliliters of sample. So the results of my test would be 7, the tube length, times 1500, the tube factor, divided by 3. That would be my answer as far as sulfide ion concentration in milligrams per liter or parts per million. So that basically is the way you run a Garrett gas train test for H2S analysis. From here we will clean up, we will disassemble, remove the set screws, disassemble the unit, clean the unit out and get it ready for the next test, which is how you do with all of your testing equipment. At the end of each test, you want to make it ready to do the next test without having to do any cleanup for the next test prior to starting. So that's it, the Garrett gas train H2S analysis test. This is Larry Mitchell. I thank you for your attendance, and as always, call us or email us if you have any questions and or comments. Thank you very much.